with different insects. Today we have opportunity to watch some very tiny insects. I have shown you already them, but they are very tiny, so difficult to recognize them, difficult to make a magnification of microscope. And today I'm trying to make magnification of my camera. Yes, because these insects are very tiny. These are tiny egg parasitoids of moths. These are Trichogramma parasitic wasps. Why they are so tiny? Because they are parasitoids of eggs, and eggs of insects are very small. They have size just half of millimeter. Yes, 0.5 millimeter size. They are sitting here in mass number. Why, you can say? Because they just hatched. They just emerged from eggs. Because they are egg parasitoids. They emerged from eggs of grain moths. Here, a huge number of them. A lot of tiny dots crawling around, like sitting inside this tube. They're like tiny ants. But these are not ants, because they are small, much smaller than ants. They are very tiny. They are sitting in different tubes, because they are belonging to different samples. And here a lot of eggs of rain moth. Yes, a lot of rain moths gave a lot of adults which have been developing inside eggs. That's why they just hatched and crawling inside in captivity in closed chamber inside the last tube. I'm just moving from one glass tube to another glass tube. I cannot make huge magnification like on a microscope, because I'm using simple cameras just for direct online translation, just to attract attention to biological control agents such as Trichogramma and other Hymenopterous insects. And it's quite fun to show them, because they have size like flower mites, half of millimeter, but they are dark. Their structure is the same like for honeybee, because they belong to Hymenoptera order, but because they are parasitic wasps, but they are tiny parasitoids, tiny parasitic wasps. They're not predaceous, they're not phytophagous, they're parasitic. They're eating eggs from inside. They're growing on eggs of rain moths, different moths and butterflies in natural environment. And if you can collect eggs of butterflies somewhere in nature, keep it in captivity in glass tubes on plastic tubes, you can image them pretty often, because they can be spread everywhere in different countries, in different ecological system, in different environment. Many species have not been described yet, because you can see these insects are very tiny, 0.5 millimeter. 15 species have been already recorded, and in Ukraine, on the territory of Ukraine, and over 100 species are known just for the world. But they're still weakly studied, because it needs to unite taxonomical study of morphology, ecology, trophical relations, distribution, and also sometimes, and pretty often used, study of DNA. DNA study is very useful for identification, because you see many of these insects here in large number, but they are very tiny. For their morphological differentiation, some morphological characters are used, which are very variable, like structure of male antennae, structures of wings, and male genitalia. And male genitalia of different species are pretty close. Sometimes close, sometimes very different. It depends from species, depends from their distribution, depends from their trophical relations, depends from the quality of work, for sure. But in some cases, if used DNA study, it's quite helpful to differentiate similar close species or cryptic species, which is difficult to differentiate using morphological characters. We're sitting here in this cage in large number, just because we just hatched from grain moth Citatroga cerearella. I cannot make a huge number small. I cannot make huge magnification because for my previous video I used different microscope, and now I'm just taking video directly online from a glass tube with thousands tiny specimens of Trichogramma egg parasitoids, important biological control agent of agricultural crops. If you can collect some eggs of butterflies, some eggs of beetles, sawflies, maybe you can raise some egg parasitoids in captivity, in your glass tube, in your plastic tube, in your cage, whatever you are living on, in Africa, in America, in Australia, in Southeast Asia. These tiny parasitoids are spread all around the world. Their taxonomy is weekly studied. Many photos you can find in internet, but only scientific papers are scientifically proved for identification. And many species are mixed and needs confirmation of identification. Thank you for people who is coming to our stream. Thank you from Britain. The host is rain moth. Rain moth, just very tiny, which is feeding on a grain of wheat, for instance, in laboratory, and Latin name Citotroga cerearella, very common species. In Southeast Asia, different species can be used as well for laboratory study, for laboratory breeding. If I can give them natural hosts from natural environment, like fresh eggs of Saturniidae moths, Pyralidae moths, Noctuidae moths, they will be very happy to parasitize them and infest them in captivity. And it's quite useful to use artificial hosts just received in natural environment, propose them for these tiny insects and take a photo of their behavior, because they are very happy to crawl around the eggs, fresh eggs, with like a fresh food, and infest them immediately after such kind of proposal of new food for infestation. And then it's possible to receive more individual from infested eggs, so to get some number of eggs. Yes, Citotroga. In some cases, it's possible to use just such egg traps. People are gluing eggs on some cardboard and put some cards with attached glued eggs in natural environment somewhere, on bark, on leaves, on trees, on shrubs, on rain, and then you can collect these eggs next day, next morning time, with possible infested eggs. It's possible to catch some natural species from natural environment on such artificial egg traps. But to be honest, this host trap is not the best way, because it is quite difficult to attract natural species from natural environment to host trap. Some ants will be coming in, some ants will be feeding on eggs, and percentage of parasitization can be not very high. The best way to find natural host eggs somewhere on plants, on leaves, on stems, on branches of trees, maybe on some fruits, and rear these parasitoids from natural eggs to know just precisely the name of host, and then propose them laboratory host in captivity in laboratory. So in this case, it's possible to know host egg place and host name more precisely, and to breed them in certain number in laboratory to receive females and males. Most important to receive males. With females, it's possible to multiply culture, to have more individuals, and with males, it's possible to study them, to identify them after making microscopic slides. Actually, in this tiny tube, I guess so about 2 grams, and heat could be in this tube at least 20-30 thousands of these tiny specimens. So 30,000 tiny individuals like one honeybee swarm, just in one glass tube, which is not very big one. Maybe size 4 centimeters and depth 1 centimeter size. Actually, one female is producing not many eggs, up to maybe 40-50 eggs for parasitization. So productivity is good one. But the process of breeding, releasing is quite difficult. And actually they have not very active behavior for spreading around the place of distribution. They're not excellent flyers. They're slightly crawling and they can be spread by air around and just by artificial release for sure. Because they are used with some substance or some kind of substrate together. Infested eggs are mixed with substrate and released somewhere in garden, in orchard, together with substrate, because to don't damage eggs, because eggs are very fragile and very tiny and cute. Actually, I do not rear them for fun because I received this material from commercial biological laboratory, which is breeding them just for commercial purpose, for trade, for use them in agricultural fields. This species is used in Ukraine to control corn moth, Loxostachys ticticales, on corn moths, on infested by corn moth fields, or slightly infested or highly infested in some organic agricultural farming places. So that's why Trichogramma is used for organic agriculture instead of using of insecticides, pesticides, and so far and so good. This is a short introduction of Trichogramma egg parasitoids. This is my short video about Trichogramma just online, because they are just crawling here around and making dirty this glass tube because of poo and pee. And later it will be difficult to show them through the glass. And my interest is pure scientific. I am identifying species which is commercially bred, have been bred in laboratory. So it's important to control laboratory culture, to know what species is bred, has been bred in laboratory. So that's why my scientific interest is mixed with their practical interest, because some species are more effective on agricultural fields and some species are less effective. Thank you for interest and curiosity. See you soon on my channel. New streams. Thank you for coming this time. I was pleased to show my nice parasitoids just online, because I did high magnification pictures and video of Trichogramma under another microscope, but it was more difficult to show them online because they are crawling very fast under the high magnification, and on screen I can receive just only a few numbers of them. But here in a glass tube I can show you all of them together, thousands of thousands, despite some dirty surface of glass because of pee and poo of them. Nevertheless, you can recognize so many of them because they are tiny, half of millimeter size, as I said. So this was a Trichogramma Petri dish video with Trichogramma, biological control agent of agricultural pests. This was video from Kyiv, capital of Ukraine. Best greetings from Kyiv. And don't forget, stand with Ukraine, support Ukraine, help Ukraine, and Ukraine will win. Thank you for interest and curiosity, scientific interest, scientific curiosity, in science, biological control, in agriculture. Thank you. See you soon in next stream. Don't forget to subscribe, press like and write your comments.